Thank you very much for having me today. We are looking at chapter 6.2 for today, measuring electricity. So we're going to begin with the concept of current. I need you to turn to page number 227, page 227 on current. So it's stated here that current is a flow of charge which transfers energy around a circuit. In an electric circuit, this flow of energy or this flow of charge is made up of electrons moving along the wire. There's something you have to be very clear. What is moving on the wire when we are talking about a complete circuit? You have your wire, and I'll try to draw this. Usually you have your light globe. Let's just say it looks like this here. You have your wire. And let's just say in this case you are given a cell. Make sure you know the difference between a cell and a battery. If you're talking about a cell, you're talking about one. If you're talking about more than one cell, you're talking about battery. So battery is a collection of cells. It can be two or more cells. So in this case, if you're talking about movement of the current along the wire, you're talking about the movement of electrons. If electrons are not moving across the wire, you do not get any conductivity. The light group will not be growing. So in this case, if you're talking about current, you're talking about flow of charge. And you are actually talking about the flow of electrons along the wire. Alright, I'm moving on to the second paragraph. It says these electrons and the current they form carry energy around the circuit from the battery or power point to the different components that use it. It says the current can be direct or alternating. If it's direct, it's one way. If it's alternating, it's back and flow. So it's going forward, it's going backward, and so on. So that is the difference between direct and alternating current. So I'm just going to move on to the next slide. Alright, so it's stated here the amount of current going around a circuit is measured in amperes, or amps for short is given the symbol A. If you come across A, you are talking about the use of ammeter, as you can see here. Ammeter, if you look at this symbol, it's written there as A. So ammeter measures the current that passes through them. And ammeter needs to be in line with the rest of a circuit. We will talk more about parallel and series circuit in the next lesson, but for now you can see that this is a complete circuit. So just give me a second. As you can see here, so I'm highlighting this for you. You can see that this top part here, this is a battery because it's collection of cells. You have your ammeter to measure the current of the circuit, and you have your light globe. Alright, so using this method, we will be able to measure how much current is passing through the wire. So in this case, in the circuit itself, because you are actually measuring the amount of electrons that is passing through the wire. I'm moving on to the next slide. Alright, so now we're talking about voltage. So there are three main terms once again on electric circuit. You have current, you have voltage, you have resistance. We are covering resistance in the next few lessons, but for now we are talking about voltage and current. So when you're talking about voltage, it says here, voltage is a measure of the amount of energy supplied to the charges by the voltage source used by the charges as they pass through a component such as light globe. And this energy is transformed into heat and light. There's something you have to be very clear. Voltage is the measure of the amount of energy that is supplied by the voltage source. So the voltage source usually that you're talking about in a circuit is your battery or your cell. If it's one cell, it's considered as a cell. If it's more than one cell, it's known as the battery. So there's something called the voltage drop, because when the voltage is passing through your light globe, for example, initially there's an electrical potential that has been built up towards the light globe, but the voltage drop is important and needs to happen because the voltage is now being used by, or the energy is being used and transformed by the light globe into heat and light. That's the reason why you're able to see that it's growing and it's releasing heat. and that is the reason why we have this voltage drop. It's a conversion of that electrical potential, and the energy now has been transformed into heat and light. Alright, the second paragraph says voltage is measured using a wattmeter. The voltage is high, so electrons are supplied with a lot of energy and are losing lots of energy. The voltage is low if the electrons lack energy or lose very little. If the voltage is 0, then it means the battery is dead and the power point is turned off. You have to be very clear. If the voltage is 0, it means that no energy can be transformed into other forms of energy because electrical potential is not there. There is no electrical potential that has been built up towards the light globe. So when we are talking about voltage, the way we measure voltage, or we use the wattmeter, the electric currents, because we are measuring it in the form of ampere, we are using ammeter for that. Alright, so in this case, you say the unit to measure voltage is watt. Make sure you very clear if you're talking about voltage drop. If you are talking about the measure of amount of energy, you are referring to voltage. If you are calculating the amount of electrons that is going through the wire itself, you're talking about the electrical current. Alright, electrical current. Because voltage has to come about. So you have to mention the amount of energy that is coming from the supply or the electrical supply. That's the reason why you have your battery or your cell, because you do need them to supply a particular energy towards your light globe. Alright, move on to the next slide. Supply voltage. So now we are talking about different forms of supply voltage. Main power, which is what you're using at home. At the moment, if you're charging your laptop, you're charging your phone, you are using the main power. So usually what it does is that you do need to have a transformer. As you can see at the bottom here, if you're using a laptop, you can come across a transformer. Why is it important? Initially, you have a voltage of 240 volt on your power supply. If you're going to supply it straight into your laptop will die straight away. It will be very dangerous for electrical, because they're having too much voltage for what they can manage. That's the reason why mobile phones here in this 5 to 6 voltage, the camera 6.5 voltage, laptop 19 voltage. Go and take a look at the charger. If you take a look at your charger right now, you'll come across a transformer on many of your electrical device. It is to reduce the amount of voltage that is going into your electrical device, because you want to prevent it from taking in too much voltages. Alright, move on to the next slide. So now we are talking about battery. Batteries are excellent source of portable electrical energy. Batteries are generally made up of small cells or smaller mini batteries. Batteries connect to the rest of the circuit. So once again, if you have one cell, you're talking about cell. If you have more than one cell, you're referring to as batteries. So in this case, you have wet cells. If you have many cells are joined together, then it's known as a battery. So you have wet cells, dry cells, and photovoltaic. So three main cells that we are talking about for today. In general, wet cells are the one that you use in car. Dry cells are the one that you're using, let's just say, if you have a toy, if you have let's just say a remote control at home that you want to use a battery or cell, you're talking about dry cell. Solar cells will be, let's just say, those that you use in your garden that has solar panel on it, or if you have any solar panel installed on the roof of your house, that is also considered as the photovoltaic or solar cells. Moving on to the next slide. Alright, so I'm going to begin this with the wet cell. If you're talking about wet cell, it has conducting electrodes submerged in liquid electrolyte, a solution that conducts electricity. Electrodes are rod sheets or plates made of metal or some conducting material like graphite. The electrolytes in a car battery is a solution of sulfuric acid that conducts electricity. Alright, so, and it says wet cell provide relatively large voltages, last long time, and can be easily recharged. So what you need to get out of this slide here, you will come across the positive terminal. You'll come across the negative terminal, and then you have your electrodes as well. Can you see that? The electrodes, and you have your electrolyte. Alright, and you may be aware as well, when we are talking about the positive terminal is also known as the anode. negative terminal is known as the cathode. So you can use a particular way of memorizing this. There's something known as panic. So I'll write this for you. P-A-N-I-C. So panic is positive is anode, negative is cathode. So I repeat myself. Panic stands for positive is anode, negative is cathode. So the point here is that you have electrons that builds up at the anode, which is the positive terminal, and the electrons builds up at the positive terminal. Alright, the point here is that the electron wants to go from the positive terminal to the negative terminal. But the electrons cannot move through the electrolyte. Why? Because the electrolyte is preventing, or the electrolyte here is negative charge, because of sulfuric acid, is preventing the electrons from moving straight across from the positive to negative terminal. So what it needs to do now is that it will need to go through the wire in order, or go through the car in order for it to go to the negative terminal. And that is exactly what it wants, and ultimately is able to power the engine as a result. Alright, because the electrons cannot move direct from the positive to negative terminal, it needs to go into the car engine before it goes back to the negative terminal. So you see here at the bottom diagram, a battery is used to start the car and to power lights and radio when the engine is not running. When driving, a device called an alternator recharges the battery. So now we are able to power the lights and radio, which is within the vehicle itself. And that is the general idea. It's a movement of electrons across the wire from the positive to the negative terminal. So ultimately saying that this will recharge because this will reverse, the process will sort of reverse in terms of the movement of electrons. When the engine is started, you have this alternator that recharges the battery and ultimately allowing you to keep reusing the battery itself when you are powering the lights and radio of your vehicle. Alright, so I'm just going to move on to the next slide. So a dry cell, this is what you use at home. Once again, the concept is still very similar as you can see here, and you can use the same principle. You have your positive terminal, you have your negative terminal, and here you have your electrolyte. What is the purpose of electrolyte? It's to prevent the electrons from going straight from the positive to the negative terminal. And once again, you can use the same principle that we have. So panic, P-A-N-I-C, which stands for positive is anode, negative is cathode. Positive is anode, negative is cathode. So your positive terminal is where the electrons will build up. The electrons will build up in the positive terminal. It needs to go through the light group, through the wire, before returning to the negative terminal. It cannot go straight through the electrolyte. Why? Because the electrolyte is negative charge. It does not allow the electrons to go straight, and that is what you want. You want it to power the light group that you have in your circuit or any devices that you have at home. Think about it, when you're using a remote control or you're powering a battery, you're powering like a toy, for example. You want the current to go through, or the voltage, you want the voltage to go through the devices that you have at home. Alright, so if I am going through here, it says dry cells are compact because they have one electrode wrapped around another. It says they don't leak because they use a conducting paste as is electrolyte instead of a liquid. So it's known as the dry cell because the electrode that is being used here is dry. It's a conducting paste instead of a liquid, such as sulfuric acid that you see in the red cell in the previous slide. So I'm just going to move on to the next slide. Alright, so you can see here, if you are stacking up the cells, in this case, each of these is known as one cell. So you have, let's say here, you have one cell. Just give me a second. So you have one cell, you have one cell here, you have one cell here. You can see here by stacking up the cells, eventually you can get the cells that you see in the right cell. So if you have 1.5 multiplied by 8, you will get 12. So 12 voltage is what you see in a car, the wet cell in a car vehicle. In this case, if you stack out the dry cells in your house, you should be able to come across the same voltage as the one in a vehicle. Alright, so different batteries will have different voltage. That's why they have been used for different reasons. But ultimately, this is the whole point about using batteries, and you're talking about the energy is coming from the battery itself. That is why we are calculating in the form of voltage, because we are talking about voltage drop. Eventually, there will be a voltage drop from before it goes through the light growth until after it goes through the light growth, so that it shows that the electrical potential has been used, that the voltage has been used for that particular light globe to light up the globe. Alright, moving on to the next slide. So we are moving on to the last concept here, photovoltaic cells. So if you're talking about photovoltaic cells, you're talking about solar panels. So it says convert solar energy directly into electrical energy. This is the energy in the sunlight knocks electrons off silicon crystals within a cell. This electron move away from the crystal, forming electrical current that can be used to power appliances. The current generated by photovoltaic cells can also be used to recharge batteries. The point here is that you have your solar panel. If you come across solar panel on the rooftop, how it works is that it converts solar energy into electrical energy. It says the energy in the sunlight knocks the electrons off the silicon crystals within the cell. This electron move away from crystal. You are always talking about movement of electrons. If electrons do not move, there will be no electrical current. You see the same principle with a dry cell, with a wet cell, with the solar cells as well. The electrons have to move for electrical current to move as well, to be used to power appliances. Which is why if I'm going to move on to the next slide, and I'm moving on to the next slide now, which is the last slide, you can see that, let's just say that you have a garden, that you have this garden light, the solar array, how it works, you have solar cell, you have solar module, you have solar array. So you have very tiny solar cells, and what they use is that they convert sunlight energy into electrical energy. Eventually it's used to recharge the battery for the light, and if we enable the battery to be used, let's say at night, to power the light bulb that you have in your garden, which is why you do not need to recharge it yourself. It will be done automatically if you do have these photovoltaic cells or solar cells that you have on top of these garden lights. Alright, so think about these different cells when you are at home. Think about what you're using and how do you have this voltage drop that ultimately enabling you to power up your light globe or any devices that you have at home if you are using a battery or cells. Alright, so before I end this, you do need to complete the questions on school boards. Check on the questions on school boards page, and if there is any quiz, and once again you should have completed your quiz for chapter 6. There will be a chapter 6.1, there will be a chapter 6.2 quiz next week. Make sure you do complete chapter 6.2 quiz next week when it is being written on school boards itself. For now, if there's any other questions, if there's any worksheet questions that is written, you do need to complete them, or any online tasks, check out that page, check out the schedule that we have for today, and do complete all the questions. If you have completed textbook questions, upload it onto social stream, so that we can discuss the questions that we have. Thank you very much.